I'm going to go ahead and do that. All right, there we go. All right, thank you everybody for coming to and joining us with the Globe SMAP Soil Moisture Field Campaign February webinar. And we have a lot of really cool things to tell you about, and especially we're celebrating 1 year of SMAP in space. And that's exciting, even though it doesn't mean that SMAP has been taking measurements for an entire year. It has been in space for over a year now. So we're going to talk a little bit about that, and we have SMAP scientist Dr. Erica Podest on the line on the webinar, and she's going to be talking to you a little bit about more specificity regarding the SMAP mission and you know, what it's measuring, and you know, what we can expect out of SMAP in the future. So I'm going to run to slide 2 here. So 1 year of SMAP satellite in space. Erica, would you like to take this slide?
Sure, Brian. Thanks very much, and thank you for everyone that's joined the telecon. I'd like to kind of go over all of the exciting things about SMAP since its launch. So as you know, we launched on January 31st, 2015, and the first 3 months were a commissioning phase. So that means that was the time period when we ensured that all of the systems on board the satellite were working. And it wasn't until about mid-April that the science phase began. And that's the period of time when we started collecting science data on a continuous basis. So since then, we have collected about 416 gigabytes of SMAP radiometer data. And that translates into about 13.3 million soil moisture measurements throughout our globe during this period of time. So we continue to collect data. We're still in what's called the calibration validation phase. So that means that we're ensuring that this data is validated. And we are making all of the data available through a NASA archive center called NSIDC, and it's all freely available. So I don't know if you have a link to that further on, Brian, but you guys can go download the data, and there's some tools there where you can visualize the data as well. So we're very excited. We have these global soil moisture products. They are at 36 kilometers resolution, and the science team has also been very creative in doing other things with the radiometer data, and one of these is looking at sea surface salinity. So this example that you see here, this chart, can we play it, Brian? Yep. That video has 2 products. One is soil moisture, global soil moisture throughout a period of time. That's over land. And then the colors that you see over the ocean, that's salinity, sea surface salinity.
It was popped on my screen. Hold on a second. Not sure where it went. Let me go find it again. There we go. Disappeared on me. Here we go.
There you go.
For the full screen. All right.
So you can see over land, there's how soil moisture varies, and the areas that are yellow over land are areas that are very, very dry. Areas that are bluish are areas that are that have a large amount of soil moisture, very wet. And then over the ocean, areas that are pinkish are areas that have low salinity, and areas that are yellowish and reddish have high salinity. So usually you find low salinity if you look at the mouth of the Amazon. There's a lot of fresh water coming out, and you can see that plume. A lot of interesting things. I mean, you can look at this video for hours, but also in terms of soil moisture, if you look at India, for example, you can see the onset of the monsoon season. So right now, if you look at India, very dry, and with the progression of the video, you'll suddenly see a drastic change in soil moisture over India there. It's starting, and it just starts getting very, very wet. So a lot of cool things. And we're still obviously acquiring data and looking at how things are, the variations in soil moisture globally, and of course other products like this one, salinity, and there's a whole community out there of users, application users that are starting to use soil moisture data in their weather prediction models or in their flood forecasting models or drought prediction models. So a lot of excitement in the community.
So Erica, can you say anything about what the difference is between, often we hear the data coming from satellites and then we hear something about what's called data products. Can you give a little difference between those two?
Yeah, absolutely. So the data is what the satellite is observing. So it's like if you have a camera and you take a picture of, say it's your garden, right? So the picture has content on grass, and there's a tree in your garden, and there's some flowers. The data product is what is derived from that data, from that image. So in the case of the picture of your garden, then the product would be like a map that has, say, 3 different colors. One color is the grass, another color is the tree, and another color are the flowers. So that's a product.
Okay, excellent. Thank you. Yeah, as you heard from Erica, we have really great things going on with the SMAP mission, really exciting things, and we know we have many more years of SMAP satellite in orbit taking great soil moisture measurements. So a little bit about where we are with GLOBE, and this is the most recent map of all the GLOBE schools that are taking SMAP soil moisture measurements using the block pattern soil moisture protocol. So compared to last month, you see there's a lot more in the United States. Croatia always looks like that because they always do awesome stuff. They're always really excited about the GLOBE protocols, and a little later on today, you'll hear from Croatian teacher Marina, and she's going to talk about how their school is collecting soil moisture data using this SMAP soil moisture protocol. So this is the current map of where we are, and of course, the larger the circle, the more measurements have been taken. And you'll see East Coast is pretty well represented. I should say the Northeast in the United States, as well as up here in Michigan and into Ohio. Also California has taken place, and Puerto Rico. And I see Richard is online, so thank you, Richard, for joining us. He's from Puerto Rico, and you'll see in Croatia here, pretty much covered most of Croatia here. So excellent work. So what I decided to do this time, and I'll give you the method for why I'm doing it this way, but I have this familiar looking chart here with the list of all the schools and how many measurements have been taken. Now, we've had a bunch of schools that have had problems, some form or another, with taking measurements and submitting them to GLOBE. Either it's a connectivity issue or things like that. So they're actually retroactively putting their measurements into the system currently. So the numbers would be skewed if I did it month by month. So I'm doing a total SMAP block pattern data counts from now on because of because people are adding things that the measurements that they took maybe in November or October. So it's easier to get and more accurate to get the full count. And as you'll see, if we break this down, in the United States, we have 45 schools participating at 67 different soil moisture sites for SMAP. In Croatia, we have 11 schools, sorry, I shouldn't say 14 there, 16, it should be 13 schools at 16 sites because 2 more schools joined in. And then we have Puerto Rico. The Egypt one is actually a test site being done by GLOBE, Trinidad and Tobago, Oman, and Italy. So with all these put together, in the United States, it accounts for 493 measurements, Croatia, 318 measurements, and then 67 Puerto Rico, 9 Egypt, which is a test site. We have to include it, but Trinidad and Tobago 9, Oman 44, and Italy 9, which gives us a total of 949 data counts. We didn't hit the 1,000, but when I say that, we have officially 949 mapped ones that you can find on the Globe SMAP soil moisture map. Sorry, on the Globe Viz map. But as you know, there's been something new that has been added, and it's to define your soil state. So basically, I'll go into that in a second, but if your soil state is considered immeasurable, meaning frozen soil or some of the other precipitation on the ground, if you submit that data currently, it does not show up on the Globe data map. The Globe program is actually working on this, on that infrastructure in order for it to show up. And I know there's lots and lots, at least 100 measurements that have been put in there as immeasurable, taking it over to that 1,000. So congratulations, we did hit 1,000. It's just not showing up on the map yet. It's only at 949. So we're pretty close to getting that set up. So the Globe team is actually working on that to make sure that those things are measurable. That the immeasurable ones are actually able to be viewed on the Globe map, the visualization map. So we actually did get over 1,000 measurements. Oh, sorry, I need to say something here, is that you see the color coded again. So currently in the lead with 132 measurements is Osnovna Skola Varadin at Marina's sites, and she's going to be talking a little bit about that later. In second place, we have Bowling Green State University. They have 10 sites actually set up. They have 109 measurements. And then we have a tie for third place, and that is the Ramey School in Puerto Rico and the Shoemate Middle School in Michigan. So congratulations to everybody. And we have a bunch of new schools. Thank you so much to the SciStarter group and all the SciStarter schools. If you don't know, SciStarter is a group that is working to get more and more teachers in the United States equipment to take these measurements. And they have been working with all these schools. You'll see all these that say SciStarter on them. Oops, sorry. SciStarter on them are all part of this one program. So that ranges all across the United States. So thank you so much for SciStarter, Darlene Cavalier and Dixon Butler. Actually got it started with a nonprofit he runs called Y-Laces. And it got started that way. And then he went to SciStarter, and then they got the ball rolling and getting all the equipment out, the grants, the monetary grants submitted to these, got the monetary grants to these schools, and then equipment was purchased so they could take the measurements. So that's a great way to do it. So congratulations to everybody. And we have a couple that have really been taking a lot of measurements lately. The SciStarter in Florida, it's called their soil moisture site #1. They actually had 24 measurements. A couple other ones, Pomperaug High School in Connecticut has 22. So I mean, they're going fast and furious. Alfred State College with 41. So we have lots of good schools here. And then Croatia is just very impressive. Just 13 schools with 318 measurements taken. So that's really exciting stuff.
Yeah, hey Brian, I just wanted to add and thank everyone for participating in this, and let you guys know that it's very valuable, the measurements that you're collecting, because as scientists, what we do is we compare your measurements with SMAP's measurements. And if they agree, then it gives us confidence that SMAP is doing a good job in making soil moisture measurements. So now that we have certain schools that have many measurements over time, now we can really start comparing and seeing whether we are following the same trends. So I think in the next webinar, we'll be showing some of those comparisons, but we're very grateful, and it's been very useful for us to have your measurements.
Yes, I think that's such a vital thing when the students can actually realize that the data that they're taking isn't just for them learning, it's for us learning as well at NASA. So it's great stuff, and it's, you know, really valuable science data that the students are taking. All right, so a couple of things here. What's new? I mentioned earlier about soil states. You might have seen an email that came out. When you enter live data via the SMAP block pattern protocol, you will be prompted after you enter the date and time of your data collection. You will be prompted to define the soil state. And you are given 6 choices. The first one is measurable. That means that you can easily collect a sample. You know, you can dig in, you can grab the soil, nothing's frozen, no precipitation on the ground. It could be a little wet from rain, that's okay. But it's measurable. So then you go and continue like you normally do. You enter the drying method, and then you enter your weight measurements as well. But the newest part of this is if you have something that's impeding your data collection, and that would be that would be selections of frozen ground. Basically, the temperature of the soil has caused it to freeze. If there's snow on the ground, if there's grapple on the ground, if you see here, grapple is basically soft hail or snow pellets. If there's hail on the ground, basically if there's lumps of ice on the ground where you'd be collecting the soil, or if there's frozen water covering your soil sample site. So if you enter one of those 5 things, a box will pop up that says non-measurable soil state selected. And what's going to happen there is if you haven't done it yet, is in the comment section, you can say anything. You can say, oh, there's, you know, my site, you know, is frozen, or, you know, it contains grapple or snow, and then you send the data, and then it'll record it as immeasurable. It'll give you credit for taking data. It'll give you credit for submitting data, because all that information is very important. It's important for the SMAP mission, especially, to know exactly what the ground is like. You know, because we have that satellite in space that can determine if the soil is frozen. So it's good for us to know that also as a source of validation for the satellite data. So it's very important to have that. And we worked with Globe in order to get the most precise and scientifically accurate things in there that you might experience. So that's the first new thing that is exciting, that you can actually take measurements. Because I had a couple people email me saying, you know, we've been taking measurements and all of a sudden the ground's frozen and we feel guilty not taking measurements. So now they can actually take measurements and submit these as non-measurable, but you still get credit for that. And those will show up, as I mentioned, pretty soon on the map. Okay, something else that's very exciting. There's this new SMAP data layer in the Globe visualization map. And I have a step-by-step process here if you want to take a look at this. You click on the visualized data on the main page, www.globe.gov. You know, everybody who's knows Globe knows how to get to this. But you click on visualize data, and then the map pops up. And then about midway through, on the light blue bar in the middle, you'll see it says choose a science data layer. And you can scroll down under SMAP, it says L3 soil moisture. So you click on that. And what you get here on this third box, what you get here is this map that's showing the SMAP data. And what you do if you want to determine what day you'd like to see the SMAP data, let's say you took your data measurements on January 6th of 2016. Well, what you do is you go all the way over here and you click on measurement tab. There's a little measurement button there that shows up. And what you do is you click here, and then the calendar will pop up, and then you click what date you want to look at. So then what happens is the second you click that date, the SMAP map of soil moisture will pop up for that day. And then if you want to look at your school's data in comparison with the SMAP map, that's a tough thing to say, SMAP map. All right, to look at the SMAP map, you just add the SMAP data pattern, the SMAP pattern data layer as you normally would, just add layer over here, and then scroll down to the SMAP one, open that, and then it'll bring up, like I brought up earlier, all the different schools, and then you can find your school, zoom in, and this one, for instance, is one of the schools in Croatia, If you can then look over here at the volumetric soil moisture and then look up at this color bar and see how well it matches up to this. So this is basically color coded, and you can look at the volumetric, which then we have a little bar down here that's saying, you know, what the colors mean. And then you can actually take a look at, compare your data to the actual SMAP satellite data and see how close you came to that. And that's one of the things that Erica is looking at as a SMAP scientist. They're looking at that correlation between how well your data matches up with the SMAP data. And as she mentioned, you know, if your data matches up, that means the satellite's doing the right thing. So that's very exciting and really cool to see it finally up there. So you can take a look at that as well. Okay, one thing I really wanted to share with you is something called Eyes on the Earth. And I don't know if anybody's used this before, but it's a really cool product out of the NASA Jet Propulsion Laboratory where Erica is based. And what you can do is you can actually go and look at satellites basically live where they are, but there's lots of other things you can look at. But I just want to show you what you can do here. So I'm gonna stop sharing this and go to the app. So I opened up, if you go to the website, I'll go back to that, you can click that website. And I'm gonna share my screen here. Let me go full screen. All right. Can everybody see that map? Erica, can you let me know that you can see that, the globe?
Yes, I can see it.
Okay, great, thanks. So this is called Eyes on the Earth, and what it does is you can look at all the information from all the individual satellites that are listed here. But let me go up here. Up here you see a little image of a satellite that says missions. You click on that, you have all these awesome NASA missions you can take a look at, but I'm going to click on SMAP. So here it's showing SMAP and how it moves around the planet, and you can actually move the planet like this to see where it is. But down here in the bottom right, it says real time. So if you click on real time, this will show you exactly where the SMAP satellite is right now. So very cool. You see it's just looks like it's going over the North Pole or close to it right now. So very, very cool stuff. It actually shows, you know, where it's nighttime. You can see over here, there's Croatia right there. Still have some lights on there. But as you move over towards where I am, I'm right here. And then Erica is over here. So we have lots of people. We have Richard's down here. So we have lots of cool things you can see on here. So this happens to be SMAP. And then you can go over here and learn about different things about SMAP. One thing that's cool is you can actually look how big SMAP is compared to a scientist. So it'll zoom in. It'll show the satellite next to a scientist standing there for relative size. Then you can measure it up with the size of a school bus. And that's how big SMAP is. So it's a very cool site, and you can check out some awesome things related to this. So it's really, really neat to see. I just want to share that with you, and I'll pop back up here and show you the URL again. I'll get out of here. I'm going to stop my share, go back to this new one. All right, so if you want to, you know, I'll give you a second if you want to copy down that URL. It's really cool to see. Or you can just Google NASA Eyes on Earth. Either way. So it's really cool to see. It's a really cool thing to do. You can explore a bunch of different satellites, and you can look exactly where specific satellites are right at this moment. All righty, now we get to the exciting stuff, and so I can be quiet. So we're going to start off first with Vicki Gorman. She is a teacher at the Medford Memorial Middle School in the USA in New Jersey, and she's going to talk a little bit about her school and how her students are taking measurements and all the fun they're having. So I'm going to stop my share, Vicki, and you can go ahead and share your screen. And then unmute yourself. We can't hear you.
You should be able to.
Now we can. Now
Okay.
you're good. Thank you, Vicki.
Okay. So hello, everybody, and welcome to everybody across the globe and the United States. It's about 4:30 East Coast time in New Jersey. My name is Vicki Gorman, and I'm going to be talking to you about our students and the SMAP campaign. As Brian said, there's a map just to let you know where we're located. We're about 22 miles east of Philadelphia and about a 45-minute drive to the New Jersey shore. So we've got the best of all worlds. This is not an area that you would see on The Sopranos with, the turnpike and all the built-up areas. We actually live in a lot of farmland. And it's actually a beautiful place in New Jersey. Here's just some pictures of our town. You can see it's fairly quaint. It's got a main street. We have a small airport that sports the swimming pool in the shape of a plane, which the kids always love. We have old mills that have been in existence for 100 years or more. So it's a suburban area because even though it's rural in some respects, we are so close to built-up areas that we do consider ourselves a suburban environment. Now, I did want to point out, just because we're talking about soil, that New Jersey sits on, and especially we down in this area, sit on one of the most prolific aquifers, or some of the most prolific aquifers in the country. Our water table is often very high, and in fact, we border in Medford, we border the New Jersey pinelands. And for those of you who don't know what that is, it's just basically scrub pines, a lot of sand. New Jersey used to be under ocean water a long time ago. People in Philadelphia actually had beachfront property. But our soil here at the school, if you look at this PowerPoint, our school is built up on, and there's housing developments on these brown areas, but all the green areas are considered wetlands. So we have a lot of hydric soil, a good amount of soil moisture. Even on the school grounds, we have a marsh that's enclosed with a fence, and we have low-lying areas that if we get any amount of rain, the Canadian geese can come and swim and call it their home. So I just wanted to quickly mention our citizen science education program. The students of this program are the ones that are working with the SMAP campaign. And this is a program that started 2.5 years ago at our school. These two students that are featured here, Nola and Jess, were 7th graders, and they thought that they would enter a contest to win $5,000 and thought it was going to be easy and said, let's come up with a project. And they decided on a project where our middle schoolers go out into the community and teach citizens about science to improve their scientific literacy. But part of the program, besides that, is for the students in CSEP to participate in campaigns that work with scientists and actual science protocols so that they can become junior scientists as well. And we do a lot with satellites and remote sensing because that's where one of my loves and passions. We worked with GPM last year. We're also working with GOES-R this year and next year. So here are some photographs of my students when we first started. You can see where we're doing it right out of the back of school, and in that middle picture, that door, I don't know if you can see my cursor, but that door is the door to my classroom, so it's really easy to come out the back and do the protocol. It's a fairly flat area, and it's not super close to any trees and buildings. When we first started, we didn't have soil cans, so we thought we would use coffee cans and put a piece of masking tape where you would have the 2-inch or 5-centimeter level, but it didn't work very well, and we ended up always getting way too much soil, and it couldn't be entered in the SMAP database. So we also learned by trial and error that we needed a strong 2x4 and we needed a rubber mallet instead of anything that was made of metal. And we also, for protection now, wear goggles when we go outside because at one point the wood split. But we've now since, this is our SMAP corner. It's a corner of my classroom. My classroom is pretty chock full with a lot of different things. But you see now we actually have soil cans that I got from forestry supplier. And the only thing that we do a little bit different than the protocol as it's written in Globe is that we pour our dirt into these sort of like meatloaf aluminum pans because they dry faster. So we, of course, measure the aluminum pan. The kids go out with the soil moisture can, get the sample, and then pour the dirt into the meatloaf pan, and that's what we put under our heat lamps. We have 2 100-watt heat lamps and a 150-watt heat lamp, and it usually takes about 14 or 15 hours to dry. I can't leave these on when I leave, so I know there's some moisture that's probably absorbed overnight, but my room is not super moist. So there's just a closer look, and of course we have our very large graduated cylinder for the volume measurements, what the kids just think is hysterical that they make a graduated cylinder that large. And then we have our Play-Doh to put in the little hole in the can when we take our volume measurements. Here was just a picture I sent to Brian at Christmas time. The kids wanted, they call him Scientist Brian, and they wanted to send Scientist Brian Christmas greetings. And so they went out with some antlers and a little reindeer covering. And here they went out to take a picture and show you how disappointed they were that they couldn't take their soil measurements for a while. Medford got about 20.5 inches in that last nor'easter that came through. Although I will say today, and this is probably not necessarily good for SMAP, but there was a little tiny area that was totally melted, and it happened to be the next hole in the block pattern. And they came running in this morning and they were like, we can do it, we can do it. So the rest of the ground is a little bit snowy. So SMAP with its resolution is going to probably see snow in this area, but the kids were so psyched that they could actually get their soil moisture measurements. The only thing we haven't done, and I'm really excited, Brian, you gave us all the information today, is we haven't actually seen the visualization of the data from SMAP. So I think it will really bring home to the kids that scientists are using this data and that ground validation really has a place in all of this, as they call it, NASA stuff, which sort of has this ambiance of, you know, shock and awe. But anyway, that's it. If anybody ever has any questions about starting a program like our Citizen Science Education program, or just wants to know more about New Jersey, there's my email address, and that's it.
All right, thank you, Vicki. That was great. So how about I open it up right now to anybody who wants to ask Vicki some questions about it. And I especially like the idea that you figured out the using the meatloaf tins actually will help dry it a lot faster than the Ziploc bags. I mean, whatever works the best for you, but still falls within the lines of doing it correctly is great, you know, because people will modify it based upon what they see, and that's one thing to be expected. You know, we set up the protocol, and those are guidelines to follow, but if something works out better and you're still doing it scientifically accurate, if your science is accurate, and then it's great. So does anybody have any questions for Vicki or any ideas, anything you'd like to discuss with her? If you'd like to, just unmute.
Yeah, my only comment, Vicki, is so when you collect the sample with the can, do you cover the can?
Yes, we have. There's actually a cover that goes with the can as well, but we found that the outside air pressure holds that cap on too strong, so we take a plastic, well, I guess it's plastic / rubber top from a coffee can and just hold it over the soil can until we get inside. But the kids come inside and immediately put it in the meatloaf pan, and the walk is not that long, but we do cover it. Yep.
Excellent. Any other questions? Okay, great. Thank you so much, Vicki.
Yep, my pleasure.
And now we will go across the world to Croatia, in the central part of Croatia, and we will be hearing from Marina. So Marina, you can go ahead and share your screen and talk about everything that your school has done. Make sure you unmute yourself, Marina, before you share your screen.
So, hello from Croatia. Can you hear me?
Yep, we can hear you.
Okay. So, it's 10:30 p.m. here, so I'm ready to sleep, but it's okay. So we are a third primary school, Varaždin, and we are in a GLOBE program for 2 years. We have 2 SMAP sites near the school. Here on the map you can see here's our school, and here are SMAP sites. They are all in the range of 1 kilometers. We have only 2 students doing SMAP, but as you can see from the results, they are very hard working. Here you can see Sandra collecting data before school. She's collecting it with a plastic bag, and then she's weighting them and drying. When she's drying them, she tears up the plastic bag, but the soil is still on the plastic bag. She realized that the drying is faster in that way. And sometimes, well, most of the times, we are using radiator as a heat, and sometimes lamps. Nenad is also collecting data in his home yard before school and drying it, and after he gets home from school, entering data in Globebase. And that's it from me. If you have some questions.
Not a question, but just wanted to thank you. And it's very encouraging to see that 2 students really have taken this so seriously to collect so many soil moisture measurements over this short period of time.
Yes, in fact, I told them that they don't have to do it every day. It's enough to take measurements 3 times a week, but they wanted to do it every day. I don't know why, but they like it, and it's okay. It's great, in fact.
Good.
Excellent. Any more questions for Marina? Or comments? Yes, I just want to echo what Erica said. Thank you so much, and thank you to your students, and we'll talk to them soon. You know, thank them greatly for their dedication, and you know, as I mentioned, we'll talk to you soon. So Right, I'm going to finish up here. Is Kristen on from Globe? Okay, so basically, that would be a Globe update, what we'd be doing. But I think what I discussed with all the new things, the soil states, as well as um, the SMAP data layer are the newest things as part of this. And I'll send a message out when everything is viewable on the map, especially the immeasurable soil states. Also, please check out the blogs. You know, we've added some blogs in the last few months as well. You can get that directly from the SMAP Soil Moisture Field Campaign site on Globe, and post any questions or comments you have. And I put in the comment in the section, in the comment section about if you want to be if you want to be a presenter at our next webinar, please feel free to let me know, because everybody likes to hear from schools across the world. So just a reminder, if you want to take a look at, you know, how to do the protocol, if you haven't done it yet, I know some people might be just getting started, but we have on the Globe website, the SMAP campaign website on Globe, the SMAP volumetric soil moisture protocol video. So it's an instructional video. It's, as you see, it's 11 minutes and 44 seconds long. So it's a really in-depth video of the step-by-step process and how to do the protocol. So feel free to check that out. And then also I put together here, and I'll send this, I'll put a link up to this presentation as part of, actually, I will send out the link to the webinar recording, and this will be on there. So you'll be able to see this. And these are a couple resources I'm going to share with you, all about the NASA SMAP mission. That's the official SMAP mission page. We have something called Know Your Earth. You can look and find quiz questions you might want to use in your classroom. NASA Wavelength is a repository or database for lots of good educational materials, specifically geared around the electromagnetic spectrum. NASA Scientific Visualization Studio is a visualization studio where you can find basically any type of visualization or video related to NASA Earth science missions and space missions, planetary, heliophysics, things of that nature. NASA Earth, that's all about the campaign and how NASA is studying our planet right now. NASA Eyes is called, this is just a general one because the Eyes on Earth that I showed you earlier, the eyes will also take you into the outer reaches of our solar system as well. And here's the link for the SMAP Globe collaboration. And I have it set up that the next webinar will be held on March 1st, 2016. We're going to try a different time now. If anybody wants to join in with their classroom, that would be great. We're trying to just move it around because there's some schools that want to join in, but they can't because it's the middle of the night. Some of the schools, you know, like in Thailand and areas like that, where it's the middle of the night, and we want to try to get some more people involved in this. But this is going to be 11 a.m. Eastern time, and I will send out some notifications with this, a reminder with the email with the link to this webinar recording. And then also make sure you, oh, I need to change this here. Sorry, that was the old one. Sorry about that. And here, this is a link to the blogs, but you can find that on here as well. So does anybody have anything they'd like to share, any questions they'd like to ask myself or Erica or any of the presenters today? Please feel free to unmute your microphones and have at it. Thank you, Richard. You guys keep up the great science too. All right, I'll give a couple seconds here. People, if they want to ask something, they have to unmute themselves. All right, well, thank you for joining in, and we will end this meeting. It's great. Remember, if you have any questions, just feel free to shoot me an email at brian.a.campbell@nasa.gov. And thank you so much to the presenters today. Vicky at Medford Memorial Middle School in New Jersey, and Marina at Vrazin School in Croatia, and then also for Dr. Erica Potis for joining in and into the discussion and sharing some great information about the SMAP mission and what's going on with it right now and what's going to happen in the future. And as Erica mentioned, hopefully, by next webinar, we'll have some comparisons done between the SMAP satellite data and the Globe student data, since we have a lot of schools collecting lots of data and they have enough to really be able to look at some trends. Anything else, Erica?
That's it for now.
All righty. Well, thank you, everyone, and look for an email tomorrow or somebody else maybe later today, most likely tomorrow. And thank you all, and I'm going to stop the recording now.